So good day everyone. We are going to present our project on system architecture and system integration in architecture. So for our project title, UniverseX, Universal Currency Exchange. So this is my group mates. Dan David Brunyosa, and my group mates are Sean Jared Endaya and Magtibay John Leonard. So this is our statement of the problem. In today's global economy, users frequently need to convert currencies for travel, business, remittances, and online transactions. However, current currency conversion platforms often suffer from inaccurate or delayed exchange rates, slow or manual conversion process, complex interfaces not friendly for quick checks, limited currency options. So, to make a way for that problem, users need a simple, fast, and reliable tool to convert global currencies instantly with real-time accuracy. So, that's why we create the UniverseX, a web application that provides instant, real-time, and multi-currency exchange conversion in one clean interface. So, Hills. Users can convert currencies using accurate real-time exchange rates without refreshing the page. Users can complete conversions through a fast, simple interface with minimal steps. User can access and convert between 30 plus global currencies all in one place. Sponsor user. Student and teachers who need quick and accurate currency conversion for learning or teaching purposes. Travelers who want to check real-time exchange rates for before or during their trips. Online sellers and buyers who need to convert international prices for global transactions. General users who require fast and reliable financial information. So, playback. Feedback gathered from users. Through the feedback section of the UniverseX web application, users shared the following insight. Users wanted a cleaner and more modern interface that is easy to understand at first glance. Feedback highlighted the need for clearer value propositions, explaining why UniverseX is reliable compared to other converters. Some users reported confusion about where to start the conversion process, especially in mobile devices. Improvements made based on feedback. 1. Improve layout and visual hierarchy. The currency converter is now clearly positioned and visually separated using card-based design. Important actions like the convert button are emphasized with strong contrast and clear placement. Sections are spaced properly to reduce clutter and improve readability. Next, improve layout and visual hierarchy. The currency converter is now clearly positioned and visually separated using card-based design. Important actions like convert button are emphasized with strong contrast and section are spaced properly to reduce clutter and improve readability. So next, clear picture and communication. A dedicated Why Choose UniverseX section was added to highlight key benefits. For example, live rates, multiple currency support, instant results. This feature can this feature cards helps user quickly understand the system's trends. Next, mobile responsiveness improvements. Design adjustments ensure the site works smoothly on mobile devices. Scalable cards, readable text sizes, touch-friendly buttons. This directly addresses feedback from mobile users. So, proposed UniverseX system architecture.
And for the purpose UniverseX system architecture. The UniverseX system architecture is organized into three logical layers. The client layer for front end, the application layer for back end, and microservices and the data layer. Each layer has a clear responsibility and communicates with the other to deliver fast, reliable currency conversion. Key components: client, front end, HTML, CSS, and JavaScript. Specifically charts.js for graphing. This runs in the user's browser. PHP application, backend and core. The single PHP file containing all logic including the view rendering, HTML business logic, conversion, data ingestion, get historical rates, get current rate, and the ML training prediction process. External data provider. The Frankfurter API, https api.frankfurter.app, used for fetching both the latest and historical exchange rates. External ML library. The PHP-ML library, specifically PHP-ML regression list squares, is installed via Composer and executed directly within the main PHP script. Data storage. The historical rates are fetched on every request and are not persistently stored in a database. Like the microservices example, the data is temporarily stored in the historical rates array during the script execution. For the system architecture diagram, a client server is conversion request to API and to API to core exchange services, ML prediction services, to real-time rates, to external data layer, exchange rate API, to data ingestion, and to store clean data. And for the ML data flow, the one is data ingestion, two model training, and four is prediction display client. Data flow. A real-time conversion flow. This is the standard process for a user to get a current exchange rate. 1. User request. A user inputs amount and selects the source and target currencies on the client. 2. API call. The client sends a conversion request to the API gateway. 3. Routing. The API gateway routes the request to the core exchanging service. 4. Catch check. The core exchange service first checks the data catching layer for the request currency pairs rate. Catch hit. Fast path. If the rate is found and is recent, less than 60 seconds old, the service calculates the conversion and sends the result back to the client via the API gateway. Catch miss. Stale. Update path. If the rate is not found is too old, the core exchange service calls the external data provider to get the latest rate. Rate update. The new real-time rate is calculated, stored in the data catching layer for future requests, and then the converted result is sent back to the client. And machine learning data flow, training and prediction. This flow is for generating future rates prediction. 1. Data ingestion. The data ingestion ETL tool runs a scheduled job to fetch historical and recent data from the external data provider and save it to the database. 2. Model training. The ML prediction service periodically fetches the cleaned historical data from the database for training. ML process, data preprocessing, feature engineering, model training, and model evaluation. Prediction request. The core exchange service sends a request to the ML prediction service. Prediction response. The ML prediction service uses the latest deployed model to generate a prediction. Prediction display. The car exchange the service that can then catch this predicted rate and send it to the client for display. Yan. And for the library use, category, server side, server side ML, component PHP language PHP, and purpose is to perform the linear regression based prediction. And the client side graphing component is chart.js and the language is JavaScript. Purpose is to generate the interactive line graph showing historical rates and ML prediction. HTTP request component file get contents native PHP language PHP. Purpose is to fetches data from the external Frankfurter API. And the last category is package management. Component, composer, language PHP. Purpose is to manage the dependency on the PHP ML library.
ML integration explanation. Number 1, goal of ML integration. The primary purpose is time series forecasting. Number 1 bullet are the input data. Exchange rate values across a timeline, specifically 8 years of average rate plus the current live rate. Number 2 are the target. To predict the rate of the next two logical time step, representing the subsequent years 2026 and 2027 on the current context. Number 3 are the value. This offers the user a data-driven insight into a potential future direction of the currency pair, which is crucial for long-term planning, investment, or analysis. Number 2 are the specific model and library. The feature are the library use, algorithm, model nature, prediction method, and the details are the PHPML, least square regression, and the model nature details are the this is a simple classic statistical model that assumes a linear relationship between the time and the exchange rate value. It finds the straight line that minimizes the sum of the square difference between the line and the actual data points. The prediction method details are the model extrapolates this best fit line forward to estimate the values for the years immediately following the current year. The step-by-step ML execution. The entire ML process is executed synchronously within the main PHP script every time a user requests conversion. Step 1 are the data acquisition and pre-processing. The application first retrieves the raw input, get historical rates, fetches rate data from the Frankfurter API for the last 8 full years. It calculates and returns the yearly average rate. The second one are the current live rate. Get current rate is appended to this list representing the rate for the current year. Step 2 are the feature engineering, creating samples and targets. The historical rates array is transformed into format required for training the linear model. That is the cut mo. Step 2 feature engineering, creating samples and targets. The historical rates array is transformed into format required for the linear model. The time step. The sequential index is the sole feature used to train the model, making the process computationally light. Step 3 model training. The step 3 are the least squares model is trained. The model calculates the optimal slope and intercept based on the 9 data points provided. Step 4 are the train model generates the forecast. These predictions are based purely on the detected linear trend of the previous 9 data points. The step 5 are the visualization. The resulting historical rates and prediction arrays are inserted directly into the page's HTML, where the charts JS library uses them to generate time series graph, visually plotting the trend and the forecast for the user. Thank you.